All right, this video we're going to be looking at different kinds of graphs than we had before. If you look at the one that's on the screen now, they call it, I think, a stacked graph. But what it is, it uses the same scale to measure two different quantities. And here we're looking at the annual earnings between according to gender. So professional degree, that's lawyers and doctors, and the rest of them are pretty straightforward. So the males are in the dark bars and the females are in the light bars. And so I'm going to pull up a few of the homework problems to give you an idea of what they're expecting you to be able to do. They're going to have you looking at graphs and determining information from them, but different graphs will have different ways that you do that. The first question this thing asks is, what's the percentage of difference in earnings for men with a bachelor's degree compared to women with a bachelor's degree? So let's take a look and see. Here's our bachelor's degree. And we have men earn a certain percentage more than women. So these are our numbers right here. So when you're comparing it to women's numbers, you want to know how much more men earn than women. Then this is the computation you want to do. Take the difference. So we'll take 77,090, and I'm going to divide, well, actually, sorry, I got ahead of myself. And I'm going to subtract the amount women make, 57,424, and then I'm going to divide by the number of women. 57,424, and make it a percentage by multiplying by 100%. 77,090 minus 57,424, enter. I'm going to divide by 57,424, enter. And then I'm going to finally multiply by 100 to give me my percentage. 34.25%. Let me see what it asks here. It says 1 decimal. So it was 0.25. Let me come back to it. To 1 decimal is 34.2. So we'll have 34.2% more than women. So this is the key here. We're doing the comparison with women. That's why it went on the denominator side. Next, we're doing the same kind of comparison with the professional degrees. So let me scroll on up to there. So this time we're comparing this number and this number. So we got 150,095, and they're still doing the comparison with women. So they want to men earn a certain percentage more or less than women. Since we're comparing it to women, the denominator will get the female pay. So we have 102,455 down there. I may need to make this thing longer. The male earnings is 150,095, and I'll put the female in there again. And let me check. So 150,095 minus 102,455, enter. And then I will divide by 102,455, and finally multiply by 100. And to 1 decimal place, it looks like I'm going to have 46.5% more than women. So 46.5% more than women. So that would be the answer to that question there. The next question is, how much more does a male college student graduate, let me see, bachelor's degree, earn during 45 years than the average male high school graduate? So let's take a look at what we're looking at here. So now this is the male bachelor's degree pay. and the high school graduate male is down here. So those are my two numbers, 77,090. So I have 77,090 minus 46,853. Now these are annual salaries. So what this is going to give me is the difference for 1 year. Once I have that, then I'll simply just multiply by 45 to get the answer that they're looking for. 77,090 minus 46,853. 30,237. So that's how many dollars. So what you could do, well, I don't know, we'll just say we'll take our 30,000, that's dollars, $30,237, and we'll multiply it by 45 years. So the college graduate can expect to make well over $1 million a year more during their lifetimes. One thing that you should take as part of a grain of salt here, that this exact kind of pay has to hold up for the entire 45 years, and that's probably not true. I don't know if the high school graduate has greater upward mobility than the bachelor's degree. I wouldn't know without seeing some statistics. But for this problem, they expect this difference in pay to be the same for all 45 years. So it's an unreasonable expectation. Part D is the same question that we ask in Part C, except we are going to compare the females now. So now the numbers that we're looking for, I am comparing 57,424 and for the high school, 35,097. $57,424 minus 35,097. So for 1 year, it's 22,327. Then I'm going to simply take this number and multiply it by 45, just like the last question. So I can just take this and multiply it by 45. So 1,004,715. Here we have another stylograph. It's a sequence of basically line charts, line graphs, and they're going to ask you several questions about this. So part A, it says, based on the graph, approximately when did synthetic opioids become the leading cause of overdose deaths? Synthetic opioids became the leading... Oh, okay. That's just where you're going to put the answer at. So if I look on the graph, synthetic opioids have this color. So that would be this guy right there. That's the one they're talking about. And they want to know that when did it become the leading cause? About approximately when did that happen? So we're looking for this spot right here. That's when fentanyl took over or started to lead the pack. I've pulled out my ruler and I'm going to angle it to straight up and down. Come back here, pull it over, and I'm going to use my ruler to try to tell me when that year was. So I think the easiest way, these graphs have limited capabilities when they're like this. So you can only do so much. But I'm going to try to mark here and use a straight line and go back here, get back on there. And there we go. Let me take the ruler out. If I had to guess, I would say, see, 2016 would be right here. So what year? I would say in the year 2015 is what I would say is what they're looking for. It does say, but now, so there's a difficult thing here. When approximately, they say approximately. So the question is 2015. Did it happen? It happened in year 2015, but I guess 2016 should be acceptable. So I'm going to put that in and see what happens. The next question wants us to look at the overall percentage change in overdose deaths due to synthetic opioids from 2010 to 2019. Now, let me grab my ruler again so I can explain this. So we'll start from 2010 to 2019. Well, yeah, let me scroll up a little bit in here, and I will mark. There's the end of it. So let me put a mark right there. And what I'm going to do then is I'm going to take this ruler and angle it at 0. It's right about there, I think. And let me draw a line. Got that there. Okay, and then between what 2 years was it? I think it was 2010 and 2019. So let me take this and find 2010. Well, 2010 is directly halfway between. So you have to do these with a grain of salt. You're not going to get perfect. You can only get approximate answers in a problem like this. So right here, I'm going to put a mark right here, and then I'm going to angle this. Come up here, try to find the exact spot, and I'll draw a line over here. And let me get rid of the ruler. Now, like I said, this is all estimating. I'm not exactly sure. It looks to me like I'm going to put down here, my estimate down here is 2,500. I don't know. What you might need to do is expand the graph. I'm not exactly sure. So with that said, see, here's 3,500. See, here's 5,000. That's why it kind of looked like it was halfway between 0 and 5,000. Now, at the top, we have right here would be 35,000. So I'm going to say I'm going to say halfway between, maybe somewhere around 37,000, but I'm going to say halfway between 35,000 and 40,000. So I'm going to say 37,750. That's halfway between. So we want to go ahead and then take a look at the percentage change from 2010 to now. So if you remember, the percentage change is the same as the relative change. And if we want to know how much it changed from 2010 to 2019, 2010 counts as the old time. So you might remember that it's new minus old divided by old times 100%. So let's put our numbers in. The new numbers are, I'm going with 37,750. Minus 2,500. Divide by 2,500. So I have 37,250 minus 2,500, enter. Divided by 2,500, enter. And then multiply by 100%. And I have a whopping 1,390%. Now, I also happen to do the answers that they gave us because there's no way you would be able to come anywhere close to the exact answer. So if we look at all of these here, the only one that is anywhere near my answer is this guy right here. So you, like I say, do your calculation first, and then look at the answers that are available and just use the one that's closest to yours. Here we have another type of graph. It's a bar chart where you stack the bars on top of each other, and you can see that we have a total of 5 different budget items are being considered in this problem. So let's just take, for example, the public 2-year commuter, right? This $3,691 is what they spend in tuition and fees. The $99996 is what they spend on room and board. Not at Tri-C. They don't have any room and board at Tri-C, so that would be virtually zero. Other expenses is in this green here. And then transportation, books, and supplies. Now what you're going to have is you're going to have a bunch of questions asking you to try to determine information out of this graph. So these are student budgets for the various types of colleges that they can attend. Let me scroll up to uncover the first question. I hope I can have the question and the graph on at the same time. So question A of this problem asks me, which cost category varies the least among the different types of colleges? Can you explain why the category varies so little? So this is across the different kinds of colleges. So what you want to do is look for the blocks that look relatively the same anywhere. So we can see this dark blue changes drastically depending on what school you go to. Now, if you look at the light blue ones, they're not completely different here. They go from about 10,000 to 13,000, so they're similar in shape. Now let me see what red is. Red is pretty close for all of them. So books and supplies, that makes sense. You're going to pay the same for books probably no matter where you go. Let me see what 11 is. Yellow is, I mean. Transportation could be it would vary here greatly. So you go from 18 to 12 to 1,000. And then here, I like room and board probably not as much as I'm thinking the red one right now. The books and supplies. I'm thinking that that could be about the same. But let me take a look at what green, no, other expenses is too broad of a category. So let's take a look at what possibilities we have. I'm going with books and supplies, and I back it up with the fact that if you look at these numbers here, you got the 1456, but look, 1219, 1219, 1219. So it agrees in 3 different places. Well, let's see. So books and supplies is what I would click right here, and let me read the rest of it. It varies the least because students at all types of colleges need approximately the same number of books and supplies, and these don't. Well, probably, but community colleges, students don't take as many credits in general because they're probably working or something like that. At a traditional university, students may take 16 credit hours every semester, and at community colleges, they take fewer, maximum of 12 credits for a lot of students. But I would say C for this problem. That to me looks like the best answer. Let me move up, cover the next question. Okay, if you ignore the other expenses category, the general trend is for all categories to cost more as you go down the chart from 2-year colleges, starting at 2-year colleges and moving down. Let me check that out to make sure. If you look at room and board, there's no question that goes up as you go down. Then this blue box here, so what was the dark blue? Tuition and fees, that obviously goes up. Room and board seems to be tending upward. This red one is trending. I wouldn't say it's doing downward because it goes down once, but then it stays at 1,219. We want something that actually looks like it gets cheaper as you go down the list. What's the yellow one? The yellow one starts at 1875, right? Then we're at 1211, 1211, and then 1091. So that certainly goes down as you go from highest to lowest, and the dark green we're supposed to ignore. So based on this, I would say it's transportation. Let me scroll up for part C. And last, we want to do what percentage of the total cost is for tuition at each type of school. So let me come up here. What percentage is tuition for each school? So the tuition is this stuff here, 3691. And what is the total cost for that? Well, I'm going to have to add up that total bar because it doesn't have, oh yeah, it does right here. Here's the total summary. So I've got my 3691 divided by 19378. So the way you do it is this. You take your 3691 and you divide it by 19378, and then you multiply it by 100%. So that would be the same thing here. You would take, we would have our 10,961 divided by 27,032. So I'm using, that's the total, and there's the room and board. Not room and board, tuition and fees. Multiply that by 100%. And then down here, we're going to take this number and this number, 26,323 divided by 42,394 times 100%. And then the last one, we do 37,888 divided by 54,920 times 100%. Now let me see how much accuracy they need us to have here. It says round to the nearest percent, so I don't even have to go use a decimal. All right, let me get these calculations in. 3691 divided by 19378, enter, and then let me multiply it by 100%. So I would put 19% then, because that's rounded to 19. So that's what I'm going to do for all of these, 19%. So I'll do these all to no decimal places. Next one, we got 10,961 divided by 2703032, enter, and then multiply by 100%. And to no decimal places, this is 41%. Then the next one, 26,323 divided by 42,394. And we will multiply by 100%. So that's 62% to no decimal places. And then our last one, and times 100. This one to the nearest is 69%. Okay, for this problem, problem number 9 on the homework, you'll see they give us data, male and female, and it's kind of stacked. This deals with the number of college students between male and female. And they put the female in top and the male in light blue. Now, one thing you can do to get better detail, if they allow it, is to click here on this little icon. And you can see they provide horizontal lines, which is very useful. I am going to copy that. Now, these are in 100,000, so let's keep that in mind. The data is in 100,000. So here's the graph when I've brought it in here, and this is per 100,000 students. They're going to ask us a variety of questions about this graph, and I'm going to show you how to get the best answers for those questions. Here's our first question. Estimate the number of college degrees awarded to males and to females separately in 2020. 2020 is the last year. So right here, that's the males there. So whatever line that is on, I'm going to use. Let me grab the ruler. Let me put it right at the top. So the males, it looks like it's halfway between 7 and 8. So remember, these are 100,000. So that's halfway between 700,000 and 800,000. So I don't really have much choice but to say 750,000 would be my estimate. Now they have a drop down, so you have to choose from it. You just choose the one that's closest to whatever you compute here. And then for the females, let me get to the very tippy top of that and draw another line. So what I have here is, by the graph, it looks like I'm halfway between 19,500 and 20,000. So my estimate would be something like 19,750 or 800 maybe, something around these. Now what I'm going to do is take 19,800. I should have remembered this. Remember, these are hundreds, thousands. So this is really like 1.975 million. So that's what I'm going for the girls. Now let's take a look and see the options they give us. When you go to do the problem, these will be the choices of the drop down. And we can see for the males, I estimated 750,000. So the closest thing on this list is that number. So that's what I would choose for the males. And then the females was 1.975 million. And the closest for the females would be this, 1.221 million. So there'd be the females. My next question is about when were the number of college degrees equal for males and females? So let me come back up here. I'm looking, what I want to find then is I want the thickness of the purple region to be the same as the thickness of the blue region. So let's take a look here. As you can see, as time has gone on, the number of women who have taken colleges is about 1.2 million. Oh, by the way, I explained that last answer poorly, by the way. To get the number of females, you don't just read it off the graph. To get the females, you take 1,975,000 and you subtract 750,000. This would have been my real estimate for that question. So we'd have 1,225,000, which I can see is very close to the one that they gave me. Now let me continue with what I'm trying to do. So we can see here it's skewed towards females as we get into 2020. But if we go back in time, I'm trying to find that the thickness of the purple is the same as the thickness of the blue. So one way you can do that is I'm going to grab the ruler again and I'm going to make little marks. So let me scroll this 90 degrees. You could literally measure it, I suppose. Let me see how that would work. All right, so I'm going to come here and let's check this out here. If I put my little marks up here, and in fact, you could do it this way. Let's try this. Here's a way. You could just count the number of rectangles. I'm going to try that and see what happens. So if I look in here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got about 11 and a half blue rectangles for it. So I'm going to call it 11.5 for the males. And then the females, it's hard to say about that, but I'm going to go 1. And then what's the next one? 2, 3, 4, 5, 6, 7, 8, and then a little bit, 8.5, maybe 9. So not quite then. Now, as the years progress, more and more females are taking courses, and the males are, well, they're kind of going up, but not as much as the females are. So let's go to the next one. Let's try 2010 and count the rectangles and see where I'm at here. So at 2010, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll say 13 because it's kind of half chopped. So 13 for the males, and now let me check the females. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, about 13. So perfect. That means that I would choose, well, you have your choice, you have a drop down. So let's see what the drop downs are available to us. These are the choices we are presented with, so I would definitely choose 2010 as my choice. Let me scroll up to uncover the next question about this graph. During which decade did the total number of degrees awarded increase the most? So if I'm looking for the total number of degrees, I'm talking about male and female together. So let me scroll back up here. What decade did degree getting increase the most? And that's very easy to see on the graph. As you can see here, this decade here between 2010 and 2020. Why do you know that? Because the angle of this top line is stronger than any other angle of that line. Everything here is slower, 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 picking up steam here, picking up steam, and then we're at our fastest speed at the very last decade. So let me scroll down and see what our options are. Here are the options we're presented with, and I guess we found out that this is the decade of the greatest increase. Let me scroll some more for the last question on this graph. Well, it's strange to ask me my opinion and then expect me to click a correct answer, but let's see what we have here. Do you think the stack plot is an effective way to display the data? I have no problem with it. It was very clear and easy to understand. Briefly discuss other ways that might have been used instead. Choose the correct answer below. So let's take a look. The stacked line chart makes it easy to see the changing total, but a pie chart would make it easier to compare the percentages for each gender. That's true, you could do that. That's certainly one thing that you could. The stacked line chart makes it easy to see the changing total, but a double bar graph, one bar for males and one for females each year, would make the female-male comparison easier. That certainly seems true to me. The stacked line chart makes it easy to see the exact number of each gender for every year. So now I got to stop them there. These graphs are not intended to give exact numbers. So we need to ignore these two. So only A or B is possible for us. And I have to make a decision between the two of these. The stacked line chart makes it easy to see the changing total. So A and B both start with that same thing. But then they're suggesting a pie chart would make it easier to compare the percentages of each gender. The only thing about that is you would have to have a pie chart for every single year because each year the percentages shift. And you can't do that with one pie chart. So as far as I can see, the only possible answer is B. I want to show you something with this next one here. It says the infographic summarizes a great deal of information. Let me come over here, Alt-Tab, to the question itself within the book. And if you look, if I click on the infographic here, let me move this up. See what happens here is it's hidden, so you'll have to scroll through. If I print it, let me see what happens when I try to print it. So I could use this picture for the whole thing on, I'll bring that over. All right, I made it as big as I think I'm going to. Let me go ahead and start pulling the questions. But before I do, just keep in mind, some of it's hidden down there. There's information down here as well. See, what they've done is they've broken it into types of categories. They have a general percentages up here, but if you look down here, they go into specifics, like technology use is prominent, students felt their coursework was meaningful, etc., etc. Let me go ahead and grab some questions. Our first question to deal with is, within a group of 500 typical first-year college students, approximately how many would rate their drive to achieve as above average? So I need to go around and look in this thing for a drive to achieve picture. This may take some work. You have to examine, look all over the place in this thing. So let me start at the bottom. So I found it here. It's this guy right here. 74% of the students would rate their drive to achieve as above average. And they want to know how many of us 500 students would that be. So I'll take my 500 students and I'll multiply it by 74%. I happen to know that this comes out to 370. Now for the second question, which is, can you conclude that all students who text or use social media in class are satisfied with their overall quality of instruction? And explain. Can you conclude that all students who text or use social media in their class are satisfied? So it looks like actually I see technology is listed down here. So this tells me where to look. All students who text or use social media. Let's take a look. So we have 75% of the students used it, but are satisfied with it? No, I don't think you can, because there's no connection. There's nothing there telling them about their satisfaction level. So let me see what our possibilities are. What I'm saying here is B and C I'm not going to consider either one of those. So I'm going to consider A or D and try to pick the one that's best. So I say it's no, because more students use social media in class. That doesn't feel right. Let me check A. No, although the percentage who are satisfied with the quality of instruction is nearly the same as the percentage who text or use social media during class, the two percentages may not represent the same set of students. I gotcha. So what they're trying to do here is this. They're trying to compare the 74% of students who are happy with the 75% down here. But we have no way of knowing that they are the same students. I mean, they are going to have some overlap for sure, but they're not counting exactly the same students. So I'm afraid the only choice here is choice A. I've opened up Excel. I want to show you how you could make a chart yourself that could compare 2 or 3 or more different entities. So what I'm going to say is I'm going to make up some data here, and I will do A, B, C, D, and F. So this is completely made up, and we're going to go boys versus girls. And the boys, I'm just going to make some numbers up. 5, 6, 7, 4, 3. And the girls will make this 6, 5, just so they're different. Let's make this one, I don't know, 8. We can make this 3 and 2. So this is the way that you want to put the data in there. And then let's highlight the data. And remember where you go. You go into insert. And then let me see what the bar charts look like here. So you can see that's a good one right there. I like this one the best. And let me scroll up so you can see. You see they got the boys and the girls already done for, and we've got the numbers and everything. So this is how you can make yourself a comparison chart like the ones you've been looking at.